Welcome back to Mr. Hassan's Maths channel. In this video I'm going to be going through a question which I have placed in one of my P3 what's called practice papers, as P3 is relatively new. There's not that many papers about. So what I've done is I've taken a paper, a C3-4 paper, which was January 2016, and I've separated the P3 questions, the questions related to P3, put them together, added a few other questions which are from the new specification from various places, and made a paper out of 75 marks, so the students can practice just the P3 on its own. And this is a question which is one of those which are from the new specification, so it's not found in the old C3-4 papers or the C3 papers. And this is from a Cambridge Additional Maths paper, question 11 of November 2015, paper 2-3 of the Additional Maths syllabus 4037. And this is about logarithms and how to convert something from exponential form into straight line form, y equals mx plus c. And as I said, this is something new in the P3 syllabus. So this question is about some trees which are dying in a forest because of an unknown virus. They've got some data about the number of trees surviving after a certain number of years from when the virus first appeared. Okay, and it tells us that the relationship between n and t is thought to be of the form n equals a times b to the power of minus t. So that's a model that they've devised to give an idea of how many trees survive after a certain amount of time. So we got to take this relationship here and transform it into a straight line form. So that's what we're going to do first. So in order to do that, we start off with n equals a times b to the power of minus t. All these type of questions, whether it's to do with exponentials or to do with polynomials, when you have to transform it into a straight line, what you have to do is you have to take the log of both sides. Now you can take the log to any number you wish to of both sides, and it will give you the correct answer in the end. Okay, you can take the log of any number you wish to, but the most sensible numbers to take the log to the base of are 10 and the log of the natural number e, which is called ln. Okay, log to the base n, which is log to the base e, sorry, which is ln. Now both of those, you can do either of them, it's perfectly fine. And the reason why they're traditionally used is because in the past those were the buttons that you'd find on your calculator, ln and log. You wouldn't have this button with log to the base of box where you can now put any base you want. Before, you were restricted in your calculator and in the tables that they gave you, the log tables, to the log to the base 10 and log to the base of the natural number. So either of them are fine for you to use. So I would personally use ln. No particular reason, but I'm going to use ln instead of log. I'll use ln. So I'm going to take the ln of both sides of this equation. So I have ln of n equals the ln of a times b to the power of minus t. What I have to do now is I have to split this up into separate ln terms, because I can use the multiplication law. The multiplication law, if you remember, for logs is log of a product AB can be split into the log of that same base A plus the same base B. So like, for example, if you have log to the base CAB, it's log to the base CA and log to the base plus log to the base CB. You can split a product into a sum of separate logarithms if they with the same base, and you can combine together two logarithms with the same base into a product of the two separate things that you've taken the log to. So here what I'm going to do is I'm going to split this up into ln of n, and this will be equal to the ln of a plus the ln of b to the power of negative t. Okay, so now this is almost there. What I'm going to do next is I'm going to use the power law. Now the power law, if you remember, the log to the base of anything, say b to the power of k, you can write this as k times log to the base c of b. Okay, so I can use the power law here for this, and I can say this is going to be ln n equals ln a, and you're going to have minus t times ln b. So this is now in the form that we require. Now what we can see here is n and t are the variables and a and b are the constants. Okay, so if I want to extract from here what is related in straight line form, remember, is y equals mx plus c. What is our what it relates to the m? Well, that's a ln n. Okay, that relates to the y. That's our y, and our constant, our variable, sorry, is your t. Okay, this is your variable, which is your t. So this is like your x. Okay, and your ln a is your constant, and your minus ln b is your gradient. Okay, so if I rewrite this slightly and say ln n equals, you can say minus ln b times t plus ln a. It's now in the form y equals mx plus c. Okay, the variables are ln n and t, and the constants are ln a and minus ln b, and minus ln b is like the coefficient of x, so it's like the gradient, and ln a is the constant at the end, so that's like the y-intercept. Okay, so that's now in this form that we need. So writing like this is fine. Okay, that's fine as your answer, but I'm just breaking down what is actually what in terms of y equals mx plus c in this form. Okay, so there we have the answer to the first part of the question. Then it says, using the given data, draw this straight line graph on the grid below. Okay, so I have to use this data here, and I have to draw the straight line graph below. So I need to add something to this table, because we're going to have to plot ln n against t for us to be able to get this straight line graph. Okay, we have to draw this straight line. So I can't plot these against each other. That won't give me a straight line. I need to plot the ln of n against t, and that will give me the straight line. So I need to find the ln of each of these values before we start. Okay, so now I'm going to find the ln of 2000. And that gives me 7.60. So 7.60. And I'm going to find the ln of 1300. Okay, the ln of 1300. That gives me 7.17. And then I'm going to find the ln of 890. The ln of 890. Okay, that gives me 6.79. Just round everything to 3SF. And then I'm going to get the ln of 590. That gives me 6.38. And the ln of 395. The ln of 395. And that gives me 5.97. 5.97. And the ln of 260. The ln of 260. 260. And that gives me 5.56. 5.56. Okay, so we have now our table of ln n and of t. So I need to plot these on the graph below. Okay, so here I have my table and I have my grid. I need to plot these on this grid. Okay, so now I need to use ln n against t. So this will be my ln n, my y-axis. This will be my t, my x-axis. This is in hours. Okay, now, so I've got to plot from 1 to 6 for the t. That's not a problem. 1, 2, 3, 4, 5, and 6. That's fine. And for ln n, I need to go from about 5.5 up to around 8-ish. So let me just, I think I've got enough. I'll just put these as 1, 2, all the way up to 8. I've got enough space. Okay, that should be enough. Okay, now we got to plot 1 against 7.6. That's 7.6 over there. Okay, and 2 against 7.17. That's 7.0, 7.2. 7.17 is kind of like over there somewhere. and 3 against 6.79, so that's just before 6.8. That's 6.2468, somewhere over here. And then we're going to have 4 against 6.38. That's 6.2, 6.4, so it's just before 6.4. And I'm going to have 5 against 5.98. So 5.98 is just before 6, so it's about here. And then you got 6 against 5.56, 5.246, so it's below that a bit. Okay, now I need to draw these, draw a straight line that goes through these points. Okay, so I'm just gonna do it a bit rough first and then adjust it. Okay, so now of course you would do it with a ruler and you wouldn't have to adjust it so much. This looks just right to me. It's going through those points. It looks like it's going right through 8, my particular graph. Okay, not everyone might get the same exact graph, but you know, it all should be close. Let me just make this a bit thinner. Okay, so it looks like to me that this graph is going to go, if you draw it properly, yeah, it's going to go through 8. Okay, so now we've drawn the graph, and now we've got to do part 3, which is on the other page. It says use your graph to estimate the values of A and B. Okay, the value of A and of B. Now, what we know from this is we've got ln n equals minus ln b times t plus ln a. So we know that the gradient of this graph is minus ln b, and we know the y-intercept of this graph, okay, c, is equal to ln a. So we can see from here that the y-intercept is 8. So we can say ln a is equal to 8. Let me just write that down here. We know that the y-intercept is 8, therefore the ln of a is equal to 8. All right, so that's one thing we can extract. And the other thing we need to extract is the gradient of this graph. Now the gradient of this graph is equal to the change in y over the change in x. So I can actually find it in a more accurate way by just using you know, the change in y. I'll take it from, I'll use these 2 points, okay? But I'll use the ln of 260 minus the ln of 2000. That's the change in y in terms of lns. It's just some more accurate values for these, over 6 minus 1. That should give me the value of my gradient. So I'm going to do that now. So ln of 260, it's already there, but I'll just do it again. The ln of 260 minus the ln of 2000 divided by 5, 6 minus 1. That gives me negative 0.408. Okay, that's the gradient. So we can say that the gradient is equal to minus 0.408. So we can therefore say that minus ln b is equal to minus 0.408. So now I can use this to find the values of a and b. So if I know that ln of a equals 8, okay, and I also know that this means that the ln of b equals 0.408, okay, I can rewrite this as using the index form, that this is log to the base eb equals 0.48. So e to the power of 0.408 is equal to b. And for this one I can say this is log to the base e of a equals 8. That means a is equal to e to the power of 8. Okay, so I can use these to find what b is and to find what a is. So what I'm going to do is I'm going to take this value, and that's the value of b, so it's going to be positive. So I'm going to make it positive, and I'm going to raise e to the power of that. So I have e to the power of that. So I've got e to the power of the answer that I had last, which gives you 1.503, 1.50 to 3SF. Okay, 1.50 to 3SF. What I'm going to do is, just for the sake of having something accurate, I'm going to store this as my A in my calculator. Okay, I've stored that under my memory as A. And for this, I've got e to the power of 8, which I can just write e to the power of 8. And that gives me 2980. 2980 to 3SF. 2980 to 3SF, that's right. And I can keep, I mean, I know that's e to the power of 8, I can just use that like that. Or if I want, I could store it as B, it's fine. Okay, now, so there's my value of B and my value of A. Then it says, if the trees continue to die in the same way, find the number of trees surviving after 10 years. Okay, so now we have a formula connecting, we have the values of A and B. We know the formula is N equals A times B to the power of minus T, and we know now our constants A and B. So we can say the number of trees is equal to A, which is 2980, times B, which is 1.50 to the power of minus T. Okay, so it says after 10 years, when T equals 10, we're going to say N equals 2980 times 1.50 to the power of minus 10. So what I can do now is take my values in my calculator. B is 2980. No, that was my A. So B is what I stored first. So I'll just call that up again. That's okay. That's going to be the A in here. Okay, times we've got 1.50 to the power of minus 10. Okay, times. Sorry, we need to have first 2980. Sorry, so shift, recall. We need 2980. That's our B. Okay, times A, which is 1.50 to the power of minus 10. Okay, and that gives us 50.3. So we can say 50 trees. That's 50 trees roughly. Okay, then it says part 5, the number of years taken until there are only 10 trees surviving. So again, we've got our formula, N equals 2980 times 1.50 to the power of minus T. So we want to find the number of years taken such that there are only 10 trees surviving. So we've got to solve this equation. 10 equals 2980 times 1.50 to the power of minus T. So we can say 10 divided by 2980 equals 1.50 to the power of minus T. So this is the same as writing, because I don't like to have a minus sign here. What I like to do is to modify it slightly. What I'm going to do here is I like to write this, the reciprocal of 1.5 to the power of minus T is 1.50 to the power of positive T. So that must be the reciprocal of this. So that's 2980 over 10, which gives you 298. So therefore, I can take now the log to the base of 1.5 of both sides. So if I take log to the base of 1.50 of this side, and I take it of this side, I'll end up with T on this side. So T is equal to log to the base of 1.50. Okay, so if I take log to the base T, log to the base of 1.50. So I'm going to do it like this. I'll say log to the base of, that's our A. Okay, and I'm going to have 298. Okay, 298. Okay, so 298. That will give me my answer, which is 13.96. 13.96. So you can say about 14 years. 14 years it will take for the number of trees to reach 10. Okay, so there we have the answer to that question. This is, as I said, something new. We have to take the log of both sides of this equation that they gave us, okay, in order to change it into a straight line. You can take the log to the base of anything you want. I took the log to the base e, which is a natural number, and then you can transform it into a straight line graph form, and you can draw your straight line and extract from that straight line the gradient and the y-intercept, and then use that to find the values of the constants a and b. And once you find the values of the constants a and b, you can use that to work out any question they want you to find about the situation. Okay, so there we have the answer to that question. Any other questions from this paper that I do will be in the playlist that I'm going to place over here, this practice paper. Other questions about this topic will also be a topic of exponentials and logarithms from P3 will be in the playlist that I'll place on this side as well. And in the middle here you'll have a subscribe option here, and on the top I'll put the link to a P3 past paper or specimen paper, something that I've done already for you to look at other examples of P3 questions. Thank you for watching. I hope that you understood everything fine, and that I see you again soon.